I hope all of you are having a great Python web conference. I certainly am. I'm very excited to share what I've learned over the last year at 6 Feet Up. And I want to ask you, are you ready to level up your developer experience with Kubernetes? I'm not really the animated type, but I had to do that. A little bit about myself. I started a software company way back in 1998. I've been in the tech industry for 25 years. Things are not going well business-wise in South Africa, but I've met incredible friends over the years at tech conferences. I know Gabrielle and Kelvin from 6 Feet Up way back since 2006, and I joined them in 2022 to become a crew leader at 6 Feet Up. And I've made it my mission to improve the developer experience and workflow of the teams that I work with. In answer to Rain's previous talk, I'm not burning out. I play a lot. I love dog agility. I attended the IFCS World Champs for 3 years in a row. My little Staffy Jack Russell Cross Terrier and I won medals. We got 3rd place overall. I love endurance running. This is my sanity. It keeps me sane. It's my daily meditation. I ran a great time under 4 hours at the Cape Town Marathon in last year. Training is going well. 7 months away. I'm going to do it again. I'm going to improve my time. I live on the east coast of South Africa in Port Elizabeth. And yeah, my son just turned 16 and he wants a motorcycle for his birthday. So before we continue, what do I think the ideal developer experience looks like? This is going to be our benchmark that we're measuring against. So I think we all want to be set up in a few minutes, but that's not enough. I can be set up in a few minutes, but on an underpowered environment. You need enough resources to develop and run the application. And it needs to be containerized. I believe this is a best practice. We need an isolated environment, homogeneous environment that all developers share. We need the same stack. We can't run on different versions of Python and use different tooling. I feel passionate that continuous integration and deployment needs to be set up at the beginning of the project, not 4 weeks down the line, 2 weeks down the line. We need that feedback loop before we start coding. Ideally, if we can have automatic preview environments for our PRs, that's just awesome. I mean, we can run end-to-end tests from the beginning of our project as soon as those tests become available, but we can do manual QA immediately. We can show and share immediately what we are achieving on a daily and a weekly basis. And finally, we want to use the same tools to debug our dev environment, QA, and production environment. And I think many developer workflows just completely fail just on this last point. Yes, Calvin, I'm going to get him that motorcycle. Okay, so as they say in business, if you scratch your own itch, you're likely to come up with something successful because you know the problem. And when I joined the 6 Feet Up team in 2020, I thought I had a decent high-end Dell, but believe me, it was underpowered to run the LoudSwarm stack. In meetings, while trying to set my development environment, I just heard my laptop's fans spinning. So it was underpowered. And I couldn't really just switch out to a powerful game server at the bottom of my desk or start up on a remote environment because the project wasn't really set up for remote development in mind. I think we all run into Docker permission issues, especially if you're on Linux. It's either too permissive and you end up with files owned by root on your local host, or it is too constrained and you want to run some commands or install something inside a container that is limited to a single user. So these are real pains. There wasn't that much support for developing inside containers, and I would say it was difficult to debug in the QA environment. Not the project's fault. We deploy on Fargate containers, and I think at the time AWS didn't really have tools to maybe shell into a container and explore that environment. So last year, January 2022, I made this tongue-in-the-cheek cry for help. I'm falling in love with Kubernetes. And I do not lie, I can't remember when I last saw something so well thought out. And nothing in my journey the last year or so has contradicted that the feeling I had a year ago. Why do I love it so much? So I think many of you know the term declarative, but it's such a generic term that I'm offering you a great analogy just to help make this very generic, abstract term more concrete. So I was thinking of a building plan for construction or your new home. That's what the architect draws up to describe the ideal state or the desired, let's call it the desired state. I think very few homes end up in the ideal state, but it describes the desired state at least. And in Kubernetes world, you are the architect. Kubernetes is the builder. You do not run the manual commands, or you do not run scripts to set up your development environment. You have to think through it carefully, plan it, and declare it in what we call manifests. Manifests are the building plans in Kubernetes land, and it will take care of the rest. It will deploy it to the cluster it is in charge of. But it does way more than that. It does not just take the plan, build the house, hand it over, and go on to the next project. It stays there. It's like a maintenance man on your new home. It actively, and I would say sometimes aggressively, maintains the state. So don't try and put something there that you haven't told Kubernetes about. It will kick it down the road. It will kick it off your porch, and if it's not on that original plan. This is what a manifest looks like. It is not a new language. It's our beloved YAML. It is a lot more verbose. The metadata here makes the Kubernetes components talk to each other in a sensible way, and you'll see why we need the metadata. And then sometimes it's even helpful for you. But the parts that you would recognize would be the container spec, and we're running a container image built from a Docker file. We're running it with a command if there's no entry point, and we have some environment variables that we pass to the container. So this is a part of this building plan that we are going to feed to Kubernetes, or tell it to apply. Another thing I love, it just standardizes deployment. I don't have to have a different set of tools to deploy to my local dev cluster or the QA cluster or the production cluster. I use the same command line tool, or I use the same tools, whatever. If it's not command line, if tools, if you have a GitOps process, we use the same tools throughout. Deployment doesn't start in 4 weeks or 6 weeks when we deploy to a QA cluster. And this part is really powerful to me, because I'm sure you are aware of the tension between application developers, potential tension between app developers and DevOps engineers. Now we have a common language. We can be very explicit as application developers, and in the way that we should, and to describe the application in great enough detail for a system to apply it and run it. And that is the most clear way to specify this system when we want to hand it over to DevOps engineers and to take it further. And then this standardized deployment makes it very easy to switch from a local to a remote dev environment. You might have enough resources right now on your laptop, but maybe down the line the project grows. You add 10 more containers, and now you don't, and now you want to switch, and then you can't unless you are running on Kubernetes.
Excuse me, Roché, we're not seeing your slides.
You're not seeing my slides? Oh,
no.
Okay, let me stop sharing. How about now?
That's right. Thank you.
Okay. Did you see any of the presentation until now?
No, wait, I thought you were showing something else. We didn't see it.
Oh, that is a real pity. No, that's, but you can see all of the,
Yes.
okay. I think the only thing that I want to quickly go back to is, I just showed what a Kubernetes manifest looks like, and highlighted the command and the image, and the rest was me speaking about these bullet points. So now that we're back on track, another thing I love is Kubernetes adoption. The Cloud Native Computing Foundation reported this amazing stat: 5.6 million developers used Kubernetes at the end of 2021. I'm looking forward to the next report. This was already a huge increase. It has an incredibly stable API, and it's changed very little over the past 5 years. The innovation is happening on top and inside Kubernetes, and there's a large ecosystem of tools. This is the right time to jump on the bandwagon or join the train, which pick your metaphor. We don't have vendor locking. This is a truly open source project, and all of us in the community are contributing it. And it's been incredibly liberating because we can deploy to any cloud provider, or we can deploy to bare metal. We can move managed services like Postgres back into the cluster. And if you don't think that makes sense, go and have a look at how incredible this crunchy data Postgres operator is. It does all the same things that cloud provider managed services do for you. And I bet this trend is going to continue. We're going to own our data again. I did this quick cost comparison, and as you can see, there's still a lot of disparity and difference in the market. AWS is quite expensive, the most expensive for a 4 CPU, 16 gig RAM. Linode is less expensive. Hetzner, $26 a month, same spec node with a highly, I can set up a highly available cluster with 3 nodes for $78 a month. That is just ridiculous. And I am not, preferring one or the other. I just like the freedom it gives me. I can still use a managed Kubernetes service or database service for my production cluster, but I have the freedom to set up a cheaper Hetzner cloud cluster for QA and preview environments and developer environments, especially when that's where you can save a lot of cost. So this is incredibly liberating for me. So how would you adopt Kubernetes in your company? Simple. Containerize your application. I bet you've already done it. So you're so close. We don't have to do a lot more to get you there. The second bullet I feel is important. Please don't task the DevOps team to do all the planning for this and develop the workflow. Your customer, that you have to develop the experience for here is the application developer in part, later on DevOps engineers, but application developers have use cases and they need to be heard when you are planning this transition. They need to be comfortable with this. So just involve them in any case, even if they do not necessarily have that technical know-how. And then, follow that up with a proof of concept sprint, develop a roadmap, make it transparent, and organize your thoughts in this roadmap and test it with your teams and with the community. Share it with us. We would love to exchange ideas on that. So I want to talk about a few concepts, not because I think people think Kubernetes, massive complexity. And I think it's what you need to know for a developer workflow is a little bit like learning enough Spanish to order your coffee and sit in a restaurant when you go travel. You don't need to know all of it. You don't need to how to secure pods and network policy and how to specify all of that. For a start, we just need to know a few basic concepts. So a node is as close to the actual resources, the CPU, the gigabyte RAM, let's call it it's the closest to the hardware layer. And on these nodes, we have containers that run. We call those containers pods. And pods we have this abstraction. A pod is just a container running an image, just like a service in Docker. We have this abstraction called a deployment that has additional metadata to specify how do we want these pods to run. We want 2 replicas. That's one thing. This is relevant to deployment already. I'm just including it here because you will likely organize your container image just in deployments. And then finally, we have a very important concept, the service. The service is what makes your container, your pod, accessible to the rest of the cluster and to the outside world. And since pods are ephemeral, they can come and go with deployments, with releases. They lose their IP addresses when they are restarted. But services, they become a solid endpoint, like an endpoint that you can address, and they keep track of the pods. That's why the service is such an important concept. Context is just a different name for cluster. In Kubernetes, we just call it the context. So these are distinct clusters for dev, QA, and prod. We can ask, we can query the context by this simple command, config context, and we can switch the context with the subcommand use context. Namespaces live in a specific cluster. This is another very useful concept. Imagine we have this QA cluster, different developers deploying different features at the same time. The namespace gives you a way to isolate all of the whole of the application in that namespace, and it can have a separate URL, separate data store, a separate deployment in its own right that we can debug without having to deploy more infrastructure. We just create a new namespace with very simply. So I feel that I need to go into the weeds a little bit next. I imagine that most companies these days are familiar or have a Docker Compose based workflow. So I want to draw further parallels between the actual Docker Compose workflow and Kubernetes, just to continue to give you assurance that it's not that complex and it's completely within the realm of making this transition easily. This is a typical Docker Compose file, starting here, continuing there. We have a couple of services. Each service have their own image and some volumes that we mount for development, and some commands where applicable. So if we look at the front end service in Docker, we also have a front end service in Kubernetes. And this I introduced in that slide a few slides back, where you could see the few concepts I introduced. We have metadata to help the service select the containers that form part of the deployment. And we have the selector, and we also have the port telling the service, okay, this is where you will find, this is the port where that you need to connect to when you are talking to the front end. And in this case, we again have some metadata. It's quite verbose, but they serve an important role. And the most important part is our container spec, which is very similar to what it looks like inside Docker Compose. So we have an image, we have the port that is exposed, and we have some environment variables. So just remember this. This is one way of specifying environment variables in Docker. In Kubernetes. We're going to get to another one shortly. This is the Django deployment. The service looks very similar to the front end. It's just the metadata selectors that are different. Again, I'm sure you can decipher the container spec. It's a different image. It's a different command running on different ports. The first change in this manifest is now we are sourcing the environment from what we call a config map. So that's another new concept in Django. In Kubernetes, I'm going to show you an example shortly. It's a way to just combine a lot of configuration variables into a single file. We don't have dependencies between services in Kubernetes. We use this idea of an init container. And an init container, again, it's an image. Think of it as just an image and a command that runs before the container that you specify in your manifest. And once this init container completes, the main container, let's call it the main container, will start. In this case, we're waiting for Postgres to be ready. We're using the Postgres image because the PG is ready command is readily available. And we can use that to make sure that this container only starts up when Postgres is ready. And this is what the config map looks like. It's self-explanatory almost. Key value pairs. It can contain a lot more than simple key value pairs. It can actually contain the configuration, a complete configuration file. When you think of an Nginx configuration, you can put it in a config map. One more thing, a migration job is think of it as a pod or a container that can run once. You can use a job for a cron job, something that executes regularly. In this case, I found the job to be perfect for the Django migrations. It has an init container. The only difference is we're running the migrate command in this case. It uses the same configuration. So we're sharing the configuration and we're not restarting this job. It runs once and then it's done. So we don't have a single Docker Compose file. We would likely separate them into separate manifests for each of the services so that they are easily discoverable when you are opening your Kubernetes manifest directory. Some common commands and their equivalents in Kubernetes. To deploy, we run kubectl apply and the directory of Kubernetes manifests. To shell into the container, we run kubectl exec. And I admit this is a bit ugly. We need to know the pod ID, but you can set up bash auto-completion and it will auto-complete. But I'll tell you a secret about this. You don't have to actually type these commands shortly. kubectl logs gives us the logs. It's useful to know this is what you need to do and what the equivalent is. And then to delete everything that we deployed, we just substitute apply with delete. So my secret is we're not running. We very rarely run these commands these days. They are awesome tools, both GUI tools like Lens, or I have a command line tool called K9s, which I love for obvious reasons, because dog sports are a big part of my life. And it's a terminal-based client that I can just hit a key and I'm inside a container instantaneously. To set up, so we have manifests and we're ready to deploy this to something. You probably can do that without installing anything. Docker Desktop supports a Kubernetes cluster by default. You just have to tick a box to enable it. If you're not running Docker Desktop, you can install Minikube. It runs in a VM. It has its own registry. It's It's been around for a while. Very easy to install. Kind, so called because it's Kubernetes inside Docker is another simple tool. It basically runs Kubernetes inside Docker, just like it says. So it deploys a bunch of containers to start up a cluster. This is quite fast on Linux because container processes run natively on Linux. There's no virtualization at all. So for setting up remote clusters, Kops is a tool that allows you to set up a remote cluster. It supports multiple cloud providers. One line, and you have a cluster on Azure, GKE, or on Google Cloud, or on AWS. EKS-CTL is another command line tool. You say if you sign on to AWS account, you can basically run EKS-CTL create cluster, and you have a Kubernetes cluster. And then finally, this K3S is a very lightweight Kubernetes distribution. And it's not a toy, it is actually a production Kubernetes distribution, ticking all the box. And I include it here because I love to deploy clusters remotely very simply. SSH to the machine, run curl, copy the configuration file to my laptop, and replace the IP address to the remote IP. And I have a cluster up and running. That's how easy it is to set up a Kubernetes cluster today. So development tools. Okay, so we have our cluster. We deploy the manifests, but we're not developing it because the containers are running inside the cluster. We need live updates of our code into the cluster, just like we have with bind mounts in Docker. We have incredible tools to do that for you already. Scaffold, tool developed by Google. Tilt has a very interesting configuration language in I think it's Skylog. Yeah, it's a Python configuration language. I think you like this one. And then there's DevSpace. These tools exist. You can head over to these sites, and they have great documentation to get up and running. So once you have your manifest, the rest is really, really simple. What they do primarily is they synchronize your code, your checkout, into the containers that are running inside the cluster, no matter where the cluster is. So with this is a typical scaffold configuration. I'm developing my backend and my front end, and there's a folder backend and a folder front end, and I'm not doing anything special. I'm just saying, listen, sync everything inside that folder into the cluster, and the same for the front end. This pattern can be obviously be less restrictive. It can be limited to *py.py, and here I specify where my manifests are, and this is it. And I'm off to the races. I can synchronize my code into my cluster, whether it's running locally or remotely. So this is the developer workflow. Assuming you have those manifests, onboarding a new developer comes down to setting up a development Kubernetes cluster if you want it to be local, Minikube, Kind, K3S, installing the dev tool and running scaffold dev or tilt up or DevSpace dev. And then you update your code and you see it sync into your cluster. And I see that I have some time left, and let me attempt to just quickly demonstrate this. So Pam, can you just confirm that you are seeing my screen with code right now?
Yes.
Screen. Wonderful.
Yes.
Okay, so what I'm going to do is I'm going to start my scaffold command, and it's going to deploy all the manifests and wait for them to stabilize. While I do that, I'm going to quickly switch to my browser again. And this is the template that we are currently looking at. This is a cookie cutter project that we have to bootstrap projects quickly. I'm switching back, and all I'm going to do, so let me clear some space, watch for changes, just like Scaffold is at the moment. I'm going to just say hello from my Kubernetes cluster. I'm going to write the file. It will synchronize that file into the cluster, and I should be able to switch back, and the template updated. Hello from my Kubernetes cluster. How cool is that? Okay. We have a Kubernetes developer workflow, albeit a very simple one. So what's next? Follow the 6 Feet Up blog for updates on a series of Kubernetes blog posts. We just started. I'm going to go into a lot more detail. I'll stay simple and friendly and take you through all the nuances. It's not exactly as easy, always as easy if you hit some edge cases. Please tune in for that. In the meantime, use the 6 Feet Up cookie cutter to bootstrap your project with some Kubernetes manifests and the Scaffold YAML file, just to learn how we put it all together. And please stay in touch. Let us know if you need help. Let us know what's not making sense in the cookie cutter, and please engage with us. I am a developer first and foremost. Before I put my DevOps hat in, I want this to be easy, but strategically, this is what makes sense to me right now. There's a Kubernetes quiz. You'll see it in the banner. It's been advertised in the intro comments today. Please head over there. Even if you know nothing about Kubernetes, there's bound to be some interesting nuggets in the reply. I thank you very much for attending this talk, this presentation. I really enjoyed sharing what I learned over the last year. I hope I can share even more than this next year and continue on this journey. Go to the 6 Feet Up website, have a look at the blog, subscribe to our newsletters, email me, follow me on Twitter. Thank you very much.